From the beautiful southern studios of Way Happy, this is Mr. Meyer, and we are doing 13.5, 13.6. Yes, both at the same time because it's just a bunch of formulas. In fact, you see all the formulas on your screen, and so it is the law of sines and law of cosines. Now, SOHCAHTOA, Pythagorean theorem are great, but I want to stress that they work for right triangles only. Don't you dare try to use SOHCAHTOA or Pythagorean theorem when we don't have a right triangle. And so if you don't know that triangle is a right triangle, then you got to do what is called the law of sines or the law of cosines, and it really just depends on what you're given. So you got to look at your triangle, always draw the picture, and then label all the sides. You pick where A, B, and C go, right? And then you look at the drawing. And what's really crucial about knowing which one to do, it's kind of obvious. The law of sines will always have a magic pair. You will have a side and the angle opposite them every single time. And watch out, sometimes it's hidden, like in this first one. Notice I could definitely figure out what angle C is because I know a triangle adds up to 180. And then I know that I have C and C. So whenever you have a magic pair, a ratio of a side and angle across from it, you will use the law of sines, because look at the law of sines. It's this fraction, which is equal to that fraction, which is equal to that fraction. And as long as you can make one fraction, law of sines is the best. And it's fast, and it's easy, and you'll like it. You use it in cases where you are given things like angle, 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 side, or even, yes, the dreaded side angle that we told you didn't exist. It does exist. It's ambiguous. Three different things could happen. There could actually be a triangle that works with side angle. There could be two triangles that work, or there could be none. And so that's why we don't do it in geometry, because it's ambiguous. We don't know which one it is. In Algebra 2 and in Pre-Calc, we figure out which one it is and we solve it. So we'll talk about that one in class. But we will give you some side angle problems, and you can do that. So if you ever get your magic pair, use the law of sines, use two of these fractions at a time, and you'll cross multiply and you'll solve, and life will be good. So I don't know which two we'll be using. It depends on the problem, but we will do that. And then you have the law of cosines, which is a really neat formula too, as you can see. It's used for side angle side or side problems. It's the same formula three times. Kind of look at this, pause it if you want, and think about the triangles. Or think about the formula, but notice there's the angle on this side and the side on this side and the angle on the other side. They meet each other up. The rest of it is just a pattern. Notice a squared, and you notice b squared c squared minus 2bc times the cosine of a. B squared is a squared plus c squared minus 2ac times the cosine of b. And so you notice that this formula is quite an easy pattern to recognize. So let's try some. Now, I did a nice thing here. I told you to use the law of sines, and so let's do that. But later on, you won't know. You will look at a drawing, and you will be like, oh, it's not a right triangle. I'm scared. And then you'll hopefully notice that you have a magic pair. I have f and little f. So I can write my law of sines. I can say, okay, cool. 15 over the sine of 28 degrees is equal to, and now you pick any other pair that you want. Like in this case, I could use d and 33. So I'll do little d over the sine of 33 degrees. Now your good friend cross multiplication comes in here. And so what do? I cross multiply. I get d times the sine of 28 degrees is equal to 15 times the sine of 33 degrees. And then I divide both sides by sine of 28 degrees, and I get 15 sine 33 all over sine of 28. And I grab my calculator, which happens to be ready. Make sure my calculator's in degrees, because you can see all my angles are in degrees. And so then I'm going to hit 15 sine 33, yuck, divided by sine of 28. And lo and behold, little d is about 17.4. So little d is about 17.4 units, whatever they are. So this guy is 17.4. And now I can go ahead, and when it says solve the triangle, it says solve for everything. So I can tell you, by the way, I could have told you angle E a long time ago. I could have said it's 180 minus 33 minus 28. And that would be 119 degrees. So this is 119 degrees. And last but not least, I need little e. And again, I'm going to use that same thing. I had 15 over sine of 28 equals little e over the sine of 119. Now, a different way, I cross multiplied the first time. Some kids will just figure out what this is and then multiply it by that because they multiply it to the other side. And so that's a fine and dandy way too. If you want to do 15 divided by sine of 28, find out what that is, and then multiply it by the sine of 119, you would get your answer, which is 27 let's call it 95. So 27.95. And then I tell everybody, do a kind of smart check. Smallest angle should have the smallest side. It does. That's F. Largest angle should have the largest side. It does. That's E. I'm feeling pretty good. Solved a triangle. Feeling way happy at this moment. Now again, let's look at this triangle over here. Same kind of situation. I could already tell you what that is, so I'll bring my Sheila over here. Is that 60, 75? So it's got to add up to 180. So 180 minus 36 minus 39. Oh my goodness, that's 105 degrees. So 105. Now pick your magic pair. Where is our magic pair? We must have one somewhere. Oh, we do. The angle we just found, right? The only magic pair we have. So we have set it up. 10 over the sine of 105 is equal to, let's go little q over the sine of 36. I'm going to solve this now by going, here I'll use my fraction button just to ooh and ah the audiences. 10 sine 36 over the sine of 105. Sine of 105. Again, cross multiply if you want, do whatever. 6.09, let's call it. Q is 6.09 units. So this is 6.09. Again, don't use a squared, b squared, c squared because it's not a right triangle. So one more time, 10 sine 105 is equal to r over sine of 39. And that's a 39. And again, using Sheila, second enter is going to recopy. And I have 10 over 105. I just got to change that to a 39 up there. And I guess it should be pretty close. 6.52. R equals 6.52. And we got it. 6.52. We got all the sides of the triangle. We got all the angles of the triangle. Smallest side, smallest angle. Beautiful. Let's give you a lot of science problem. And we'll see you in a minute. All right, now let's try this next triangle. Now notice it's not drawn. People freak out. Who cares, right? Who really cares? You just draw a triangle. You can draw it any way you want. I don't care. It doesn't have to be to scale or anything like that. And then you just label the three angles, A, B, C. And now you can fill in everything you want. Because remember, they told you that this was 32.2. And then across from angle A would be little a. So this is an 8. And across from angle B would be a little b, and I'd be like, all right. Now looking at this, I'm like, I don't have the law of sines. I don't have that magic pair anywhere. So I have to use the law of cosines. So here we go with the law of cosines. Now it's tricky. It's got 3 different formulas, yada, yada, yada. I just treat it like this. I'm going to put the angle that's given to me on one side of the equation, right? So on the other side is going to be the angle that the side that I don't know. So in this case, it's c squared equals. That's the side I don't know. Now do the other two sides. So, all right, a squared plus b squared. Now minus 2 of those, minus 2ab, and then cosine of that angle between them, in this case, cosine of c. Or make sure that the c's are on opposite sides of the equation. That's the law of cosines. So we got c squared equals 8 squared plus 5 squared minus 2 times 8 times 5 cosine of 32.2. And now you grab your Sheila, you make sure she's in degrees, and then you go 8 squared plus 5 squared minus 2 times 8 times 5 cosine of 32.2. And I hit enter. And now realize that's c squared. So let's square root it. I'm going to raise it to the half power because I don't want to look for the square root button. And that is 4.62. So little c is 4.62. Hopefully somebody would have caught it if it wasn't, right? If it was really big. I mean, maybe somebody would have got it and I would have been happy. Now that you got that, and you're feeling good, you can go find out, you got all the sides, you can find out one of the angles. So let's go after angle A, because A is in the alphabet. And it's the biggest. I usually go after the biggest angle if you really want to know. Because I know 8's the biggest side, I'll go after the biggest angle. And so I will now go after that. Now, the funny part is I want angle A. So I know on one side I'm going to have, an A. So little a is going to be on this side. And then I'm going to have b squared plus c squared minus 2bc cosine of angle A. And now you just got to be careful about your algebra. A lot of kids do stuff wrong here. Like 8 squared equals, let's see, b was 5 squared plus 4.62 squared minus 2 times 5 times 4.62 cosine of angle A. Now realize all of this is multiplied together. So please, order of operations. How do I solve this? Piece of cake, right? Again, I'll use my fraction button because it oohs and ahs the audiences. So I'm going to have 8 squared. And then I'm going to subtract off 5 squared, so minus 5 squared. Now, usually I'd use my answer button, but I'm not going to. I would subtract off the 4.62 squared. So I'm going to subtract off. So notice I moved the 5 over to the other side. I moved the 4 to the other side. And now dividing by everything that doesn't have the word cosine in front of it. So dividing by negative 2 times, oops, not minus, times 5 times 4.62, and I get that gross answer. And then that's what cosine of A is equal to. So if you're following along, you'd have cosine of angle A is equal to whatever gross I had, 0.3822, negative 0.3822. And now I will arc cosine that, and we will get whatever the heck angle A is. So second cosine, because again, I'm solving for that, the answer, and it says it's 112.467. So 112.467 degrees. I've got angle A, 112.467. Simple adding up to 180 is going to get me the final answer. So 180 minus the answer from above minus 32.2, the other angle, and I get 35.33. And so this is 35.33 degrees. And lo and behold, we have solved the triangle. Amazing, right? All right, let's try this other guy. You got a triangle here. So again, just draw a random triangle. I don't care. A, B, C. And now I can start filling in the stuff I know. Little a is 8. Little b is 9. Little c is 7. And then I'm going to go ahead and solve this problem. So again, I have all the sides. Great. That's a good time to use law of cosines. I'll go after the biggest one, so that looks like B. So B, you're going to be my friend here. So again, it's going to be the side opposite it. So 9 squared equals the other two. I don't care which order. A squared plus B squared minus 2 times AB cosine of the angle between them. So there you go. And now I'm going to grab my calculator. If you want, here, I'll show my work this time just so it doesn't scare you so much. It's 9 squared, and I'm going to subtract off the 8 squared. I'm going to subtract off the 7 squared, and I'm going to divide all that by negative 2 times 8 times 7. And that's going to equal the cosine of B. And so now I just got to arc cosine that grossness. So if you want, second cosine, alpha F1, the formula, right? So 9 squared minus 8 squared minus 7 squared all over negative 2 times 8 times 7. Look, I did it all in one shot. Bam! 73.39. Let's call it 4. So 73.4 degrees. So B, 73.4 degrees. 73. So you can write it nicely, or I'll sneak it in the triangle, but it probably looks better if you write it in a table or something. Now I got to go find one more angle. So again, just kind of a do-over of this exact same problem. I'm going to go after angle A. So the way I go after angle A is 8 squared equals the other two sides. So 9 squared plus 7 squared minus 2. 9 times 7 cosine of 8 angle B or A or whatever. Oh, A. And now I'm going to grab my calculator because I'm used to this. And I'm going to say, all right, second enter. Oh, I guess I shouldn't have bothered with that. But here we go. We got 8 squared minus arc cosine of 8 squared minus 9 squared minus 7 squared all over negative 2 times 8 times 7. Guess that was a 9/7. 9/7. And if I hit enter, 58.4 degrees, we have angle A. 58.4 degrees. And we now can say, hey, I know the last angle because they all add up to 180. So 180 minus the answer from above minus the 73.4. And I get the last one is 48.8. So this guy is 48.8 degrees. And I jump up and down that I have all the angles. Again, smallest side, smallest angle. Largest side, largest angle. Life is good. All right, let's ask you a question about law of cosines. See you in a minute. Nice work again. And finally, for all you, when am I ever going to need this? How about if you're a hiker, huh? If you're hiking, right, and you know your cabin is 4 feet away from the waterfall, and you know your cabin is 3 miles away from a cave, and you are on your canoe, and you are oh, no, wait, you're hiking. I was thinking you were in a boat. You're hiking, and you know you walk 2.5 miles per hour on this tough terrain. How long will it take you to get from the cave to the waterfall, right? We don't know the distance. Someone's measured, they've surveyed it, they know it's 71 degrees but between the two, but we don't know how far it is because it's just too hard to calculate. I wonder how long it would take us. Well, it's 2.5 miles an hour. And if I just knew how far I was going, I could tell you how long it's going to take me, right? So let us see. So first thing I would do is I would look at this problem. It's already drawn out for me, which I would have drawn. And then I would say, all right, I need to know this distance because that's what I care about. Well, I don't have a magic fraction anywhere, so law of sines doesn't work. So I got to go law of cosines. All right, that's not a big deal. X squared equals, now the other two sides, right? 4 squared plus 3 squared minus 2 times 4 times 3. Cosine of the angle between them, 71.7 degrees. And I'm feeling golden. Going to warm up my little Sheila here and ask her, hey, can you help me out? And she says, of course. 4 squared plus 3 squared minus 2 times 4 times 3 cosine of 71.7. And make sure your calculator's still in degrees. Now, again, a lot of kids are going to think that's 17 miles, but it's not. It's got to be square rooted. So be careful. Let's call it 4.2 miles. So we're going to tell people, hey, look, it's about 4.2 miles. And so we know the distance is 4.2 miles. And now I got what? Distance equals rate, 2.5 miles per hour times time. I don't know, so let's call it t. And let's solve for this time. So I'll divide both sides by 2.5 mpHs. And I will get my Sheila out, and she will tell me that it is 4.2 divided by 2.5. She tells me it's 1.68 hours. 1.68 hours. They said to the nearest tenth, so we better change that. 1.7 hours is about what I can tell people it will take us to get from the cave to the waterfall. Have a great day. Use this in your daily life. Calculate how long it takes you to get home. And I will see you tomorrow. Stay happy.